Good afternoon, ma'am.
Good afternoon. How are you all?
Good, ma'am. Ma'am, uh, from
Huh?
last two classes, the method you are doing it, this is very confusing, no, ma'am. How to keep in mind that things, ma'am?
If you practice properly, then you won't get confused. Okay. Only thing is you have to practice because so many laws you have to apply. Right.
Hmm. Yeah, ma'am.
The only thing is you have to practice that laws. You should remember it properly. So if you remember the laws properly, then you can use however you want.
Okay.
See, only the thing is here you have to apply the logic. Okay. So no other formal method is there like mathematics here. Everything is logic. You have to apply your mind, your brain. You have to apply. Okay.
Hmm. Okay,
So
ma'am.
DMS, yes, completely DMS is all about the logic. Okay, all about the way how you think, all about the logic. So
Okay, ma'am.
shall I start? So did you complete yesterday's problem? So yesterday I think I had given this problem to solve. Did you complete the problem?
Yes, ma'am.
Okay. Take the next one. Prove the following logical equivalences. So under that, the first one, PRQ and PR negation Q R Q logically equivalent to PRQ. Taken?
Yes, ma'am.
Have you taken the problem?
Yes, ma'am.
Okay. So let me first consider only this part. Okay, PRQ and PR negation of Q part. So we have PRQ and PR negation of Q logically equivalent to. Okay. So tell me, what is here? PRQ and PR negation of Q is there. See here, in the first place, P is there. So can we take P as a common factor?
Yes, ma'am.
Yes, ma'am.
So PR is a common one. Till what time you people will be keep on attending the classes? Every time I have to switch. Okay, PR is a common factor. Now see here, Q and negation of Q is there. So if we write Q and negation of Q like this, check whether we will be getting the same thing. PRQ and PR negation of Q. So which rule you have applied?
Distribution law.
Yes, it is distributive. Okay, now tell me what is Q and Q negation of Q. Q,
False.
false. So this is by,
Inverse law.
So what is P R F naught?
P.
P.
This is why
Identity law.
Idempotent.
identity law. Okay. Therefore, now let me write the given problem. What's the given problem? P R Q and P R negation of Q. R Q is logically equivalent to. Okay. So tell me now. So we have simplified PRQ and PR negation of Q as what?
P.
So instead of this thing, I will be writing P. So rest of the thing is Q. So what actually we are required to show?
PRQ. P and Q.
Yes. Did we get it? Yeah. So we got the same thing.
Ma'am, we are supposed to show P and Q, no, ma'am?
Is it P and Q or PRQ? What you are supposed to check?
And
What is this
P
symbol?
and Q.
What is this?
Okay, okay. I thought the up one, ma'am.
Okay. Next. Prove the following. Have you taken? So next one, P implies Q implies R is logically equivalent to P and Q implies R. Prove the following. P implies Q implies R is logically equivalent to P and Q implies R. Okay. Try it out. Have you taken the problem? Guys, have you taken the problem?
Yeah, ma'am.
Yes, ma'am.
So we have P implies Q implies R, logically equivalent to. Okay. So how do you write P implies Q? Yes, in the yesterday's class, I had given you one
Q and P.
formula. What is P implies Q equals to?
Negation P or Q.
P implies Q is logically equivalent to negation of
P or Q.
P R Q.
Q.
Okay. I'll be applying the same thing. So so accordingly we must have P implies Q can be written as negation of P R Q. So consider this entirely as a Q. So shall we write this as P R negation of P R Q implies R. Is it okay?
Yes, ma'am.
Now I'll be applying the same thing once again. So because U implies V is equals to negation is logically equivalent to negation of U R V. Okay, so now apply the same thing. Here also U implies V is there. So if U implies V is there, again you will be writing this as negation of U R V. So instead of U I am having Q and instead of V I am having R. Therefore I will be again writing this as negation of Q R negation of Q R R. Okay, because again the same thing, U implies V can be written as logically written as negation of U or V. So together we got this as negation of P or negation of Q or R. Now I will be writing this as negation of P or negation of Q or R using the association. Associative law. Now see here negation of P or negation of Q is there. So this can be together written as negation of P and Q R R. Is it okay? Using
Yes, ma'am.
De Morgan's
using
law.
De Morgan's law.
now see here. If U implies V is there means you will be writing this as negation of U or V. But if negation of U or V is there, shall we write this logically equivalent to U implies V? Is it okay? I have taken in the reverse manner.
Yes, ma'am.
Yes. So if U implies V is there means you will be writing it as negation of U or V. Now instead of U I am having this complete negation of P or Q and instead of V I am having R. So shall I write this equivalent to P and Q implies R? Is it okay?
Ma'am,
Is
you
this
have
okay?
used U implies V, ma'am.
Because negation of U or V is logically equivalent to U implies V. So what is there in place of U? P and Q is there. What is there in place of V? R is there. So apply this. Negation of U or V is logically equivalent to U implies V. So instead of U, you have to replace P and Q, and instead of V, you have to replace R. Is it okay? Did you understand?
Yeah, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Okay. Over.
Yes, ma'am.
Next one. Prove the following. Okay. Have you taken?
Yes, ma'am.
Now, I will make this as first portion and this as the second part. Okay. So together we need to show that that compound proposition is equivalent to R. So I have divided these two into two portions. So first one is this and second one is this. So first let me simplify this portion. So we have negation of P and negation of Q are R, logically equivalent. So I'll be just rewriting this as negation of P and negation of Q and R. I have used associative. Is it okay? Next. So next, since negation of P and negation of Q is there, I will be rewriting this as negation of P, R, Q and R. Is it okay?
Yes, ma'am.
So what is this?
De Morgan's law.
Now, I will be writing this as equivalently as R and negation of P R Q. Is it okay? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes. Instead of writing A and B, I have written B and A. So this is because of
Commutative.
Commutative law.
commutative. Okay. So instead of we got negation of P and negation of Q and R, we got R and negation of P R Q. Now I will be taking this part. Okay. And Q and R are P, sorry, and this is P and R is logically equivalent to. So we have the second portion, second part. So what is the second part? I have the second part, Q and R, P and R. So what I will be doing is I'll be rewriting this as, okay, let me write once again this. Q and R, P and R, I have written same thing. So I will be writing this as R and Q. Shall I write this Q and R as R and Q?
Yes, ma'am.
And P and R can, I will write this as P and R and P. Is it okay?
Yes, ma'am.
So this is because of commutative.
law.
Now, see here, here R and Q is there. Here R and P is there. So we can just take R and P outside and write this as QRP. So this is because of
Distributive law.
distribution. Okay, now I will combine. So for the second part, I got this. For the first part, I got this. Now I will combine together. Therefore, we will be having, therefore, negation of P and negation of Q and R are Q and R, P and R is logically equivalent to. So first thing I got it as R and negation of P R Q. Okay, R and QRP. Is it okay?
Yes, ma'am.
Is it okay? Okay, now I will be rewriting this. See here also R is there and here also R is there. So R and can be taken. Okay, so R and can be taken outside and we can write this as PRQ and QRP. Is it okay? This is by distribution. So again, I will rewrite this as R and negation of PRQ and PRQ. This is because of commutative. Because I can write ARB can be written as BRA. So see here, this
Ma'am,
can be
ma'am, you've already taken an in the comment section, no, ma'am. So how is that an again, ma'am?
R, no, ma'am.
oh sorry, this is R. Yes, yes, correct, correct. You are correct. This has to be R. Yes, because I have already taken and here R is there. Correct. Okay, na? Okay. So this is because of the commutative PRQ. I have written QRP as I have written it as PRQ. Now see here, this can be compared with negation of P. This is R. This can be compared with P. What is negation of PRP?
P.
What is that? True. Correct. Huh? This is because of
Inverse law.
inverse. What is R and T naught?
R, ma'am.
R.
This is by which rule?
Identity law.
Identity law.
So what you are required to show? And what we got?
Ma'am, I
Are they one
missed
and
that last third step, ma'am.
which one? This one.
Last third. Yeah, ma'am.
What is there here? Here I have just first portion we simplified and we wrote it as R and negation of PRQ. Second portion we have simplified and wrote it as R and QRP. So here R and is a common factor. So I have taken R and so here negation of PRQ I have written R is there R. QRP is there QRP. So using the distribution we did like this. So again here I have done the commutative. So instead of writing QRP, I have written it as PRQ. See here, here also PRQ is there with the negation. Here also PRQ is there. So this can be compared with negation of PRP. So you already know that negation of PRP is always logically equivalent to P using the inverse law. So we got this as the, sorry, this is T naught, not P, T naught. T naught, correct? So negation of PRP is always equivalent to T naught. So I wrote the same thing. So R and T naught using the inverse law. But we have one more law called the identity one. So which gives us R and the truth value will be giving in the same R itself. So hence the proof. Go through it. If you have any doubt, you can ask me. Guys, I'll do one thing. I'll send the pic of the sheet. You can copy later. Okay, shall I move to the next problem? Because you people are taking lots of time to copy the same thing. Shall I move to the next problem?
Yes, ma'am.
So whatever I do, I'll send the pic of that. You can copy, okay, in your notes later. Just take down the next one. Prove the following result. Prove the following result. taken? Guys, have you taken the problem?
Yes, ma'am.
Tell me. So you are required to show negation of P or Q, and R implies negation of Q is equivalent to this and then this. So how do you prove this? What shall we do? So what shall I write first? Give me idea.
U implies V.
Apply P implies Q rule.
Okay, so first we will be applying U implies V. Okay, fine. So let me write. So what we have negation of P R Q. Do one thing here, put the small bracket here. Then it will be easy. P R Q and R implies negation of Q is logically equivalent to, tell me. So what is your negation of P implies Q equals to?
Negation of P.
Negation of P implies Q is logically equivalent to negation of P.
P and negation
What is
Q.
and R?
P
R.
and negation Q, ma'am.
P and? Is this and?
Yes, ma'am.
R, man. R.
And ma'am.
Hey, check properly. Check your
Ma'am,
negation.
negation
R,
of P or
ma'am.
Q, ma'am.
R,
R.
ma'am.
Then why you people are telling and? It has to be P, negation of P or Q, correct? Yes or no? What is there in place of P?
Ma'am, P implies Q is equals to, ma'am. You have negation of P implies Q, you have, no, ma'am.
Negation of?
Implies V is logically equivalent to negation of U or V, no, ma'am.
Okay.
But here it is negation, no, ma'am.
Okay. So what is P implies Q? Shall we write like this?
Negation of P or
Okay, now. So let it be P implies Q only. Now tell me what is there in place of P?
P or Q and R.
Okay, so this has to be negation. Okay, so I have kept negation outside. So let it be negation outside only. P, R, Q and R are Q. But instead of Q, I'm having negation of Q only. So I will be writing the same thing. Is it okay?
Yes, ma'am.
Fine. So what is the first thing we have to equivalently show? Negation of negation, P, R, Q and R are negation of Q. Did you show the same thing here?
Yes, ma'am.
The first part of the this thing is over. Yes.
Yes,
Yes,
ma'am.
ma'am.
Okay. Now consider this entirely as negation of U and this as R negation of V. So how do you write negation of U or negation of V?
Negation U
Using the
and V.
so
De
this
Morgan's.
is
Use
equal
De
to
Morgan's law,
De
ma'am.
Morgan's. So this is this you will be equivalently writing it as negation of U and V. Correct? Yes.
Yes, ma'am.
So but what is there in place of U?
P or Q and R.
P, R, Q and R and Q. Is it okay? Shall I write like this? Yes, guys.
Ma'am.
So one
Yes,
negation
ma'am.
is already there. One more negation we got. What is negation of negation?
Cancel.
Negation of negation gets cancelled. So we are left with this. P, R, Q and R and Q. We are left with this because we have cancelled negation of negation, which will get cancelled. So we are left with P, R, Q and R and Q. Okay, now what I am going to do here is I'll be just writing this as P, R, Q and Q and R. Is it okay? Shall I write like this?
Yes, ma'am.
So this is because of
Commutative.
commutative. Yes, now I'll be just rewriting this as P, R, Q and Q and R. This is because of this is because of just
Associative.
yes, associative. Now this I'll be writing Q and P, R, Q and R. Here A is there, here B is there. A and B, I have written it as B and A. This is because of
Commutative.
now what is Q and P, R, Q?
Q.
Because of
Absorption law.
absorption law. So we got finally Q and R. So what we are required to show?
Q and R.
What did we get? So go through it. If you have any doubt, you can ask. Okay. Shall I turn the page?
Yes, ma'am.
Okay. Is there any doubt is there? Shall I move to the next one, guys?
Yes, ma'am.
Okay. Hmm. Let write down the problem. Let x be a small x. Let x be a specified number write down the negation of the following conditional. Write down the negation of the following conditional. If x is an integer, then x is a rational number.
Ma'am, could you please repeat, ma'am?
Let x be a specified number take down the problem. Taken the problem?
Yes, ma'am.
So instead of giving in terms of P and Q, they have given in terms of the statement. So let me take this as let the proposition P be x is an integer. Okay, then Q can be named as x is a rational number. Now we have denoted x is an integer and we have denoted x is a rational number. But what is there in the statement? So if x is a if x is